Hi everyone, today I'm going to explain about method of joints. Before we proceed, let me give a brief introduction on trusses. A truss is used in bridge, roof and towers. Individual pieces of a truss are called members and they are connected by joint. Each member can be subjected to a tension or a compression force. Tension force is a pulling force that acts on the end of a member, and compression force is a pushing force that acts at the end of a member. I'm going to explain on how we are going to calculate force in each member of a Fiat CR42 Falco fighter aircraft. The first step of our calculation is drawing the free body diagram. This is the free body diagram for CR42 Falco fighter aircraft. The weight of the frame is 2300 kilograms. Angles needed for our calculation can be obtained by using shift done opposite over adjacent. To calculate the external force that acts on this frame, we should know the number of supports. There are 4 supports here. Therefore, the weight got to be divided by 4. 2300 must be times by 9.81 to convert kilograms to newtons, and newton can be converted to kilonewtons to make our calculation simpler. Through our calculation, we can conclude that AY, DY, GY and EY is equals to 5.64 kilonewtons. There is no any force that acts on the x-axis of the frame because there is no any external force that acts on the x-axis of the frame. Now we can start to calculate the force that acts on each joint. We will start off with joint A. The first step is to create the equation of equilibrium. AY is equals to 5.64. Therefore, the equation of equilibrium for the total force that acts in the y-axis will be 5.64 minus forces in AG cos 4.76 equals to 0. Solving this calculation will give us the force that acts on AG, which is 5.64 kilonewtons. The value is in positive, therefore AG will be in tension. Meanwhile, the total force that acts on the x-axis will be negative AB, which is the force that acts at AB plus 5.64 sine 4.76 equals to 0, and we can find out AB is 0.47 kilonewton, and it will be in compression because the arrow will be heading towards the joint. Next, we jump to joint G. GY is equals to 5.64 kilonewton. Therefore, the total force that acts on the y-axis will be 5.64 sine 85.24 plus 5.64 minus GB sine 63.43 equals to 0, and we can figure out GB, which is 12.65 kilonewtons, and it is in compression because the arrow is heading towards the joint. 5.64 sine 85.24 can be obtained by using the forces that we figured out earlier, which is the force that acts on AG. The total force in the x-axis can be calculated by using negative 5.64 cos 85.24 minus 12.65 cos 63.43 plus GF equals to 0. Through this calculation, we can figure out GF, which is 6.13 kilonewtons, and it is in tension because the arrow is heading away from the joint. To calculate the force that acts on the joint B, we will not be using 5.64 kilonewtons. This is because there's no any external force that acts on joint B. Therefore, the total force that acts on the y-axis in joint B is 12.65 sine 63.43 minus BF sine 63.43. 12.65 is obtained from our previous calculation where we figure out what is the force that acts on GB. Therefore, by substituting the value of GB, we can figure out BF, which is 12.71, and it is in tension. To calculate the total force that acts on the x-axis of joint B, we will add up all the force that acts on the x-axis and equals to 0, which is 0.47, which is the force that acts in AB, plus 12.65 cos 63.43, which is the force that acts in GB, plus 12.71 cos 63.43, which is the force that acts in BF, minus BC, equals to 0, and we can figure out BC, which is 11.81 kilonewtons, and it is in compression. The total force that acts in the y-axis of joint F is 12.71 sine 63.43 minus FC sine 63.43 equals to 0. 12.71 is obtained from our previous calculation where we figure out BF is equals to 12.71. FC is 12.77 kilonewtons and it is in compression. The total force that acts on the x-axis is calculated by using negative 6.13 minus 12.71 cos 63.43 minus 12.77 cos 63.43 plus Fe equals to 0. Negative 6.13 is obtained by our previous calculation where we figure out GF is equals to 6.13, and it is in negative because the arrow is pointing to the left side. 12.71 is obtained from BF, and we figure out Fe is equals to 17.53 kilonewtons and it is in tension. The total force that acts on the y-axis is calculated by using 12.77 sine 63.43 minus EC sine 63.43 equals to 0. 12.77 is obtained from our previous calculation, which is the value of FC, and EC is 12.83 kilonewtons and it is in tension because it is moving away from the joint. The total force that acts on the x-axis is equals to 11.81 plus 12.77 cos 63.43 plus 12.83 cos 63.43 minus CD equals to 0. 11.81 is obtained from our previous calculation, which is the value of BC. 12.77 is the value of FC, and 12.83 is the value of EC, and we can figure out the value of CD, which is 23.26, and it is in compression. There is an external force that acts on joint E, which is 5.64. Therefore, the total force that acts on the y-axis of joint E is equals to 5.64 plus 12.83 sine 63.43 minus ED sine 85.24. 12.83 is the value of Fe, and the value of ED is equals to 12.12. Finally, forces on joint D will be dy equals to 5.64 kilonewtons, ED will be 17.12 kilonewtons, and it will be in compression, which has been obtained from our previous calculation, and CD will be 23.26, and it also will be in compression as we have calculated it earlier. That's all from me. Thank you.